Hello, good morning to one and all present today here. I would like to wish you all a very happy new year. New year, new beginnings, they say, but we believe in new year and new learnings. I, Ramsha Beg, PR and event head on behalf of Google Developer Student Club PHCET, is pleased to welcome you all to the workshop of Fundamentals of Compose. We are happy to collaborate with GDSC BITS Pilani Mirza and GDSC Veltech. Jetpack Compose is Android's recommended modern toolkit for building native UI. It simplifies and accelerates UI development on Android. Quickly bring your app to life with less code, powerful tools, and intuitive Kotlin APIs. Jetpack Compose allows you to build beautiful apps across devices on phones, tablets, foldables, Chrome OS, and Wear OS. Now, I would like you to call Kushnuma to introduce our speaker.
Thank you, Ramsha. Hi, and welcome everyone to today's event on the latest trends in Android app development. My name is Kushnuma, and I'm the GDSC lead of PHCET. We are honored to have with us Mr. Adit Lalsar, a Google developer expert in Android and a leading expert in the field. Mr. Adit is a senior Android engineer currently working as an individual consultant. He has been working with Android for about 9 years and has primarily contributed in building Android mobile products and scaling them up. We are thrilled to have him here with us to share his insights on the topic of fundamental of compose. Please join me in giving a warm welcome to Mr. Adit sir. We thank you again for your time and efforts taken for this event. So now I'll let you take over from here, sir.
Hey guys, good morning. Thank you all for actually joining on a Sunday. I know it must be a fun learning day, but then yes, let me just set up my screen and we'll get started. One sec. I hope my screen is visible now.
Yes, sir.
All right, cool. Okay, so to begin this particular session, I just want to kind of introduce you to what Android is, first of all. Just want to see a raise of hands. How many of you are actually excited to build for Android apps, native or otherwise? You can put it on the chat and I'll try to scan through the messages. Oops, sorry. Okay. Let me just quickly pop this up. All right, cool. There are a few folks who already have raised hands. All right, cool. Okay, so let's get started. Okay, so the intent for today's session is going to be a little bit of an interactive session, right? I don't want to be like a theory. I don't want to be another college seminar where you just come and attend and then go back. I want this to be a little more interactive. So I'll try and piece some Q&As here and there during the session and so forth. I'll also put up an agenda of what we're going to be discussing today, right? And I say discuss and not teach. This is not a teaching session. This is more about to kind of excite you guys for how Compose works and how it could be really powerful for you guys. Okay. So with that, just a bit of an intro again about me. As already mentioned, I'm an Android GD. I'm also a globetrotter. Things that I've already not been introduced with. I'm also a beer enthusiast. I've traveled about 9 countries last year alone. Speaking engagements, personal travel, and so forth. Okay. So Compose, though very great as a framework, has slowly evolved to what it is today. Correct. There are loads of things that happened in the Android community. I've been in the Android space for about since the beginning, actually. You know, those cupcake days, or when I say cupcake, I mean the Android 2 and Android 3 and so forth, right? The Honeycomb and so many other variety of Android versions. A lot has changed over the time. We had XMLs, we had fragments, and tons of other things. The new and the fun way to do this is to kind of work with Compose. The target is that just like this puzzle, we need to find a way to go to the top of the camp. And it's not a hiking experience. It's more about a fun experience. You can go and ship, you can go and do performance testing and all that, all in one ecospace called Jetpack Compose, right? Everything is like kind of built into the system. Now, what we're going to be doing here today is we're going to be taking all of you guys across a lot of those small little things. So I'm literally jumping directly to the Compose camp. The intention is that with the topics that we're going to discuss today, we're going to also look at how Android was built before and how Compose has changed everything. Okay. In case you have any questions, just remember my Google Meet is on. So that means if you raise your hand, I'll actually get a ding and I'll try and respond you there. Okay. If you have any questions, please do stop and I'll try and answer right there and then. Okay. So the first thing that I want to kind of highlight here is, sorry, just a second, having some problems here. Yeah. Okay. Yeah. The first thing, Jetpack Compose. Jetpack is a suite of libraries. When I say suite of libraries, there are other libraries involved in the Jetpack side of things. Compose is just an addition. It is built by JetBrains, and it is one of the most modern toolkit that you can find as of today. It's for building native apps. It's still using the native Android APIs. When I say APIs, these are functionality that is provided by the Android operating system. And when we build Android apps, you could build it in XML. You could build it with say React Native, Flutter, and whatever else. But Jetpack Compose brings a very simplified, and a very holistic view of how to develop apps, right? Now, you must be wondering, like, hey, all this is great, but why do we need Compose? Like, how does it solve anything for us? Like, all of you are students here. I hope you're all thinking to pick up a profession in the mobile industry. And you must be wondering, hey, building apps is great, but then I want to do something of my own as well. Can I choose Jetpack Compose over something else? How difficult is it to learn Kotlin? Or how difficult is it to do all these things called coroutine, dagger, dependency injection, and all those like fancy terms that you might hear in this industry? A lot of those things are actually solved. They're tried to simplify it so that any user who has some knowledge of how mobile works. When I say mobile, it is both operating systems of Android and iOS. And also sometimes if I have an Android watch, or if I have an Apple watch, or if I'm running on a MacBook or a Windows laptop, can I actually build Compose UI and start shipping there as well? It is very much possible. I'm here to say that I'm using I'm building production apps with Jetpack Compose, both for Android and iOS. And most importantly, I'm also writing for Android Auto. Those Zoom cars that you see in fancy Google I/O. You can actually build apps for those. You can also build it for your TV and your watch, and for other native platforms like the web. You can build it for your Macs, your Windows, and whatnot. This is just the UI toolkit, okay? But the underlying business logic, how to compile all those things, comes under a different topic called Kotlin multi-platform. Okay, but today's topic is very straightforward. This is going to be a very UI heavy, point number one, and point number two, it's going to be very code intensive. But I've broken down the code in such a way that you can understand it the minute you see that kind of code sitting somewhere in some Compose project. There are loads of open source projects out there. If you see any of those code in Jetpack Compose, you will be able to kind of build your own, and that is the goal for today. Okay, so before you even begin, right, we need to go back in time, right? Like, hey, what happened? Like, what made people build something called Jetpack Compose? Or why do we even need a UI toolkit? I keep saying this word called toolkit, right? So let's take a look before even Compose came, what happened, right? So toolkit is defined as, everything combined together into a single space. If you say, I wanted to build an Android app 3-4 years back before Compose, we would have started to write either in Java or Kotlin. And by the way, native apps, correct? And then you used to write code in XML, then use something called view binding or data binding, and then connect it to your the Kotlin file or a Java file, and then start referencing by find view by ID and all those things, correct? These are the golden days. We have lived with it for about almost 9-10 years now. It's still there in a lot of production apps, but all of this was kind of packaged into the operating system itself. When I say operating system, it's the Android operating system, right? And most importantly, state management was tricky. There was no like a hard binding rule. Oh, Adit, you need to do it this way. Adit, this is how the best practices are. As of like few years back, I think 4-5 years back, Google started to do something very unique. They started to give out articles and videos that are now live on their YouTube channel, the Android developers, or you could also go to developers.android.com, or even follow some of the code labs. And there were some of these kind of best practices to make the best cake you can ever do. A cake in this example is nothing but your Android apps, correct? But these practices came into existence and they have been used for a long while. It was just that there was no authority on this. When I say authority, it means Google came and said, hey, we're going to do it this way. This is one of the best practices. You can choose to follow or you choose not to. So this became a huge problem for a lot of folks, because that when I say state, right, state is nothing but, imagine you have an API call. Let's say you're building the next WhatsApp, right? the server is saying there are these 10 messages for this chat with your girlfriend or your boyfriend or your parents or whatever, right? Uh, that context that is coming from the backend to your front end is a state that there are messages. There could be an empty state. That means there are no messages. Your entire history is out. There could be another one where the messages are loading. That's another state. The other one could be a content. Very three basic uh, principles, right? Content, loading, or error. And if you start thinking like this, you realize that when you used to build in XML, right, it used to be a pain because UI was written in XML file, a very HTML, CSS kind of relationship, right? There used to be another file where you used to style it, control the business logic, write another layer to call the API, fetch the data, and then show it on a list or on a button or something like that, right? With all of this, context switching was there. So that means you had to learn not only just one language, you had to learn three. Gradle, so that you can build your damn app. Two, it was the XML. And then three, it was the Kotlin or Java. And people even today, as of today, and a lot of the companies even today, a lot of the developers still ask, hey, Adit, I know you're an expert on Android, and should we use Kotlin or Java? And that's the question that even comes from even a 7-10 years of experience, guys. The reason being, it doesn't matter what language you use or what framework you use. The point is that you build better apps, right? When I say better, it is imagine that you have Instagram on your phone and it keeps crashing every 10 minutes or so, correct? How bad that experience would be. So that kind of context switching, if people have not done the right thing on the app, then that became a challenge. And a lot of the simple things, like imagine building a list of contacts. A simple example. I'm pretty sure all of you have an Android phone, or if you're rich enough, you have an iPhone, or if you're like someone like me who has a world of two. All of you might have seen something called a contacts app. Now there's a list, and there is like you click on one of the contacts, you can see a details page. Now this is a UX pattern called the list in detail or master in detail pattern. Now, just to build this in XML, it had to be, there were so many components. Recycler view, we had to know how to write view bindings, we had to know how to do view holder pattern, adapters, and then the business logic, then write the XML for each layout, and then write one layout for just to put the recycler view together. Or in the golden days, this is way back, 2005, 2008 to 10 or something, we used to use something called the Android list view. So we didn't have those, that infinite scroll and pagination, none of those like fancy stuff. So it became a lot more complex to put it all together. That is what the idea of Compose is trying to solve. Okay, with all of this, now Compose has literally changed all of this equation. Now UI toolkit, which is Jetpack Compose in this case, is basically two parts. One is the toolkit, which is going to give you the UI components, and the other is the runtime. Runtime is responsible to do all those fancy things I mentioned before, where I'm not just building Android apps, I'm also building it for other platforms, iOS, there's web, desktop, and so forth. Now, because it's not tied to the system called Android operating system, they're completely independent. But obviously, because it's a language, Jetpack Compose is written only in Kotlin. Now, when we start using this framework, right, toolkit, we don't have to really tie and ship everything based on, oh, it's an Android 13. I can't ship this APK because no one is using Android 13 as of now. But I have this 90% of my users who are using Android 12, but the toolkit is not available to me. That happened a lot. And that's why you might realize when you start hunting down for articles on Android before the Jetpack Compose, there was something called the support library or action bar support, or if I remember it correctly, there used to be something called the app compact libraries. Now, what they used to do is any API, when I say API, it could be as simple as, math.floor. Floor is how to get the, if I give you 25.96 as a number, I just want the 25 as an integer number, and I don't want the 96. So it could make it a 25.00 and return me the value. Now, this API, for example, could have been only launched in Android 13 and not in Android 12, 11, 10, whatever else. Now, someone had to go and write, like a backward compatibility on this API. And that is what is happening here. It used to be tied so neatly into the operating system that we couldn't use some of the features. There was a time when we used to use, Java 1.6 in Android. I don't know how many of you know, but I'll still ask this question. How many of you know what's the latest Java version that is out there? Not for Android, but then what is the latest Java version? You can put it in the chat and I'll try and check it out in a second. But the two worlds were very different, right? Now, because of this kind of cohesive behavior, Jetpack Compose said, hey, all of this is great, but JetBrains and Google came up with some strategy and they said, hey, let's build it outside the operating system. And that's what's happened here. Okay. Just give me one sec. Sorry. Yeah. Now, what's happening here is that we have something called the state management. Now, with state management, you can do two things together. Okay. One, you can purely focus on just building the Compose UI. Correct. Imagine this. If I tell you, hey guys, we're going to be replicating the Facebook app, just the homepage. 3 out of 10 people will be like, okay, I can do it. Like I can figure it out. I can look at I'll open my phone, I'll see how it is, and I'll try to build it in XML. Out of those three, they're still going to struggle with writing the business logic, and they're going to struggle with, because their attention is so divided between UI and the state that they're going to be so. All three will have different variations. By the way, let's say 10 people from this group are all part of one team called the Android experts, and 3 of you would have chosen a different approach and individual to each other. That means all 3 of you would have a very different approach. The remaining 7 would be like, I'm going to Google search this. I'm going to figure out if there is an open source library to build that homepage or some tool over there. None of that is now required because state management is so critical that when any data source, when I say data source, it could be a database, it could be a server, it could be something like a simple cache file, or it could be something called shared preferences. Correct. These are few of the data stores that you could use. Now, anything that changes there can be triggered on the UI, and only the person or the component, or like let's imagine that we have the Facebook page itself, the Facebook homepage as a design, and let's say someone changes their photo. Correct. Now, imagine how difficult it is. You're seeing a post with a Mr. X, right, on your timeline of your Facebook, and that person goes and changes the photo, and the server sends you the data on your app, correct, on your mobile phone. Now, how do you go and update something that is already drawn? That is what a state management is. Okay, so that is pretty much built in. In XML days, we used to had to go and access the entire reference of that widget or that area of the screen where this content called Mr. X is drawn, right? And then you have to go and refresh the entire list and all that. All of that is out the door. We can do a lot more better. There's no context switching because everything is in Kotlin. So you don't have to even open the res folder anymore. That is where you used to write your XML code. Everything sits in your nice little thing called source tree or source folder. Inside it, you have the main. Inside that, you have something called the Java, and then your package, and then wherever you want. Now I'll show you some, production code as well at the end of the session, so that you get a glimpse of what all of this is about. But there's no context switching. You don't have to even know how you're going to manage any of the states because everything is in one language called Kotlin, and you can then adopt your thinking to a new platform called as iOS. I literally went and picked up Shift UI. I compared it with Jetpack Compose, and I had one client. When I say client, I'm not working. I'm my own boss. One client who said, hey, Adit, I want to launch both Android and iOS in the next, say, 4 weeks. Can you build this 2 screens in both the platforms? Instead of me, going and picking up another language called Shift UI, I've been a native Android developer for 10 plus years now. I would have said, no, I can't because I need to hire someone to even teach me or hire someone in parallel to me to build Shift. But all of that goes out of the context because now I can just purely focus on how to build the UI and then manage the state, and it can be then cross-platform. Okay. Most importantly, the code logic is now sorted because you're not going to be writing things like fragments and the life cycles of activities and other messy stuff, APIs that we have in the Android ecosystem. Compose can behave as an individual function. So instead of writing a class or an object or some kind of inheritance, the OOPS concept, right? You don't have to do any of that. You just have to ensure that the compose function is called in the correct compose way. Imagine that you're building that Facebook homepage, correct? Now it consists of a vertical list with multiple cards. That's the only simple breakdown of it, right? Now each of those vertical cards are going to be a composable function. Each of those circular avatar image view, where you're drawing the person's photo, the text that says this is Mr. Adit Lal's post, and then the text which says this is the timestamp of X seconds or whatever, and the photo that I have very cutely clicked of my puppy or something. All of those things are composable functions, all put together, and then it's drawn somewhere. So that is the intention of how to, put compose together. Now, having said all of this, you must be wondering, okay, I have never tried Compose. How do I even go about it? Very simple. Open your Android Studio and you can do something called as create a new project. And there's something that is already pre-generated for you. There's a template Templates are a very powerful concept. Basically, they write certain piece of code. When I click on this empty compose activity, right, I get another dialog which asks me what is the activity name, what is the composable function name of that function you want, and what kind of a theme you want. Four basic things that you can just feed it into a dialog. And then when I do this, I get something of this nature. Now, this is all done and great, but one key difference I want to kind of just highlight before we jump into any of the compose code. Just want to highlight one thing here. Now, when you see the set content here, right? Set content used to be set content view, and you had to pass something called the r.layout something, right? You had to pass the layout, and then the activity would draw the corresponding layout file and then give you the the view bindings. View bindings is just another way of saying the find view by reference IDs. So R was like your, if you're living in a kingdom, R was your the gatekeeper, or the person who would know which person lives in what house. And r.layout would be the rich class, the poor class, and stuff like that. Sorry, a very stupid example, but I hope you get what I mean. In Compose, what's happened is we are getting something called as the Kotlin functionality called lambdas. Lambdas are whatever you see as a curly bracket here, whatever I've highlighted here, set content space, the lambda, correct? This lambda is responsible to draw whatever you say in Compose, okay? So the magic somehow works like this. If you go and click on the set content and just open it as a file, this is the Android code. This is not an Android native app. This is the Android operating system code. When you go and look at it, because your activity extended, component activity, or it extended app compact activity, or extended activity, you get this benefit called, this set content. If you realize, there is something called composition context. Nothing to worry from your end. This is already, like if you already know what context is one way of controlling that I am the captain of the ship. This is how the activity is going to be initialized, and this is how it's going to be rendered and so forth. So if you have even touched on Android code before, you must be aware that context allows you to do bundles and send intents and start activities, start in services and whatnot. Very similarly, composition is the concept behind how Compose works. They are responsible to ensure that when an activity starts and ends, the compose tree, in this case, a tree, I'll come to what tree is, but that tree can either live or die, depending on what their activity is. Very similar concept like how fragments cannot exist on their own. They had to be connected to a parent host activity. Similarly, the compose code is also hosted in an activity, okay? Now, you might see something called as this orange label here, right? @composable. And you must be wondering, what is that? That is the annotation in a very Java world. The annotation composable is responsible to then take that function that you've marked that function as composable and draw that composable into the compiler. And then the compiler understands, oh, that is how the code is supposed to work, okay? Now, all this put together is how an activity even begins with, okay? Now, taking all this kind of information in, you're going to be wondering, okay, what are we going to learn today, right? So today's schedule is very straightforward. All of these are in minutes. So we're going to be thinking in Compose first. I want to kind of take you through the journey of what happened before Compose and how do you start thinking in Compose. I'm going to be explaining you with some, classic examples of how you would have drawn a screen in XML and then compare it with Compose. Next, we're going to be looking at a concept called modifiers. Now, this modifier is like the Lamborghini of the entire, like all the Maruti Suzukis and other brands. This modifier is the brains of how Compose works. With this class alone modifier, you have so many extension properties. In Kotlin, specifically Kotlin, there is this concept called extension functions. There's another concept called higher order functions. It's like when you call a function, you can pass another function as a variable. Instead of sending a string, you're passing another function in, and all those like fancy stuff that Kotlin brings you, all of that is kind of compressed down to bring a lot of magic and modifiers. We'll actually be doing all of these things in this modifiers, and it'll be around the 20-minute milestone from now. Next, we're going to be looking at the layouts. Layouts are going to be, the breakdown of, if you've worked on Android before, you're aware that there is something called linear layout, there is relative layout, constraint layout, and like thousands of other, like million combinations of things. We're going to be looking at all of them, comparing the notes on XML to the Compose side of things. So the intention of this session ideally is that when I show you a piece of code in Compose, you should be aware, oh yeah, I remember Aditlal had said something about this. And when you go read about it on, say, the developer.android.com, which is the official site for Android, when you go through a code lab or any source of material on Compose, you should be aware of how two and two work together. So in this world, 1 and 1 is equal to 2. Okay, it's not a binary world. Okay, moving on. Next, we're going to be looking at state management. And now this is a little heavy topic, so I've broken it down to a very bare bones. We're going to take a live example and then see how things progress. Okay. Next, we're going to be looking at something called side effects. Very, very vital for building, production apps where you have a lot of things that you want to do on the side, but you don't want to intercept anything that is happening on the main, the UI draw phase. When I say draw, the entire UI in Android is driven on something called a canvas. If you are aware of the context of a human language, right, the canvas, if you're friends with some artist or a painter, they first take a white canvas and then start, either scribbling on a pen, pencil, paint, brush, or whatever. Very similarly, UI is a drawing concept. Anything, whenever you say a text view, it's also drawing. When you say a button, it's also drawing. So all of this is the UI side. But if you want to do something like a business logic and Compose, then side effects helps you. So we're going to take a look at that. And then we're going to be looking at the code lab. But we're not going to be running through all the code lab, all the 12 steps of the code lab that I'm going to be showing you today. But I'll try and explain you all these topics that we have just went through in that code lab again. Okay. Now, first and foremost, in the imperative world, when I say imperative means that I have, two different components. One is the XML side and one is the Kotlin side. And let's say I want to build this, this nice little mobile phone screen, which has, just for example, a circular image view on the left edge of the screen, a text view on the top, and a text view at the bottom, something like a title and a subtitle. Okay. Now, we can take the example of Contacts app. If I have to do this in XML, I would have done something like this. Obviously, for brevity, I've reduced it down. We used to have something called constraint layout up till a couple of years back. We used to draw that image view, make it circular through some transformations, then have two text views. Okay. Now, what would happen here is that we would have something called a view group. Okay. The view group was the entire layout that you see on the right side. Okay. Sorry, I'll try and also explain it like this. So whatever you see here in this section used to be that thing called view group. Okay. Now this was responsible to draw three children inside it. That is the relationship of a view group to a view. I'm explaining all of this because then this becomes important. Correct. Now, when you see this, what happened was the circular image view that we saw on the previous slide, the text view, the two text views that we had, all of them then become components of this. Make sense? Okay. Now, when we go to, breaking it down, we used to have imperative way of writing code, right? We should write the XML in one, reference that by saying set content view in the activity code or in the fragment code. And then we used to get a reference of that. The reference we used to be val text view is equal to find view by ID. The ID that you should give to those children used to be then accessible like this. And then you would say something like this, text view.text and then blah, blah. Circular image view.set image is equal to URL, blah, blah. Not going into a lot of those details, but you get the intention. Now, comparatively, when I come to the exciting part of Compose, which is called a declarative UI, it kind of brings a lot of thought process. So we're going to take all those points into account now. Declarative UI is more cleaner because we're going to be writing everything in one single file. And we're going to be, organizing the code in a certain way. Most importantly, it's more readable. I don't have to say, someone built a layout for me in XML. Now I don't know where the layout is a reference. I will go right click it, find usages, find one activity code somewhere or some fragment code somewhere, and then, find reference by ID. I had to open two files together. None of that is the problem now. More importantly, it's more performant because now you don't have to optimize for the XML, If you realize XML is also deserialized. That means when the XML gets compiled into the APK is the format of the app. When it gets installed in a phone, it had to be decompiled and then, drawn when that screen was loaded. Whereas in Compose side, you don't have to do any of that because it's more performant because everything sits in the thing called Kotlin and you can optimize for it. Okay. Because of this, just a homework for you guys, learn what baseline profile is. If you have questions, we'll try and target it later. Not the topic for today, but just understand that there's a huge difference of when you write everything in Kotlin, the UI, the logic and everything, versus say something like XML. Okay. Now, more importantly, Compose kind of allows you to kind of reduce your compile time a bit. I've lived through the days where I used to literally go on a, like a, for people, even though you're in Mumbai, I'm still going to take this as a reference. Let's say I used to go to Marine Drive, drive all the way back, and then come back while my build is running. That is how long the builds were. Sometimes 20 minutes, sometimes 30 minutes. That is how bad a couple of years was. With Compose, a lot of those equations have changed. With a lot of improvements to the build systems and even Compose just doing everything in Kotlin, we are seeing a huge pump speed, like 98% reduction. That is a huge benefit. More importantly, Kotlin and Compose together as Unity is very intuitive. You can start learning Kotlin very quickly, and at the same time, you can start picking up Compose as what we're going to learn today. You can start learning this and start implementing in your production days, right? So Compose is kind of what you see is what you get kind of approach, right? Meaning, you write something on text, you get it as is. You can literally write some Compose lines of code, and you will see what the preview of it is. Whereas in XML, you have to open the preview. If you have to do state management, you have to go to you have to run the entire app, write a different state in the Kotlin code, and then expect what happens on the XML side. But having said all that, Compose is very much compatible with any existing code. You can do interop between XML and Compose. You can have a Compose function being triggered inside an XML, or you can have an XML code being triggered inside a Compose function. So you have both ways, right? And most importantly, you have the plethora of libraries called Jetpack. Now, this is a homework for you guys to understand how many of those are there. Even today, I think I would have used only 30% of the Jetpack libraries. There's so many out there that the Android team is coming out with over the years, right? Next, Compose kind of improves the build time, as I've already mentioned. More importantly, the APK size is reducing. The reason is, in XML, if you guys have even touched writing an image view, and if I say, hey, this is this, I'll give you a, like a Figma design, or Figma is one of the platforms where you can design your something like Photoshop, but seeing it on person. I can give you a Figma design or a sketch design. Sketch is a competition to it. If I take that vector file and I tell you, hey, please draw it on this image view that is there on the screen, we had to first ship a drawable file and then compress it down and all that nonsense. With Compose, a lot of those vector files are now Kotlin files. It's not, even though it's a like a very UI driven thing, you can still do it in Compose, which we will see in a little bit. Okay. Now, let's say I want to do this declarative UI. I want to say something called hello Adit. How would you go about this, right? I'm going to be writing a function. And as you can see here, I've done very simple things. I've written this as composable, right? I've annotated this function. And one more thing that has happened is that I made this as G, capital G. You just have to remember one thing: when you're writing compose functions, it is completely opposite of what others would say when you don't do compose. When you write a Kotlin function, usually you will write something like a small greeting, something like this, right? Small g. None of that is now required. The reason for that is because when we do compose function, you're going to be making it a capital G so that it is very easily readable that it's a compose function. Not that this is already there, right? This already exists. So it's nothing unique about it, right? Now, if I have to draw that hello Adit, correct? Instead of saying Adit hard-coded, right? Like, let's say there are 100 plus people on this call. If you want to run this app for yourself and you want to be, you're building an app which wakes you up in the morning with an alarm, and when you open the screen, you will see your name over there. Let's say you want to do something like that. So how would you do this? It's as simple as writing this kind of a code. The classic difference here that I want to just bring out here is that we have written something called text. This is another compose function, correct? If you realize, this is still a Kotlin function. This is the start of the function. This is the end of the function. Oh, sorry, my bad. Oh, yeah, sorry. Yeah, and this is the end of the function, correct? What we have done here is that we have taken a text view, literally a text view, which is another composable function, and called it inside another function. This is what is called a higher order function, okay? Now, when I do this, there's a property which is called text, correct? And if you realize, I have used something called the string interpolator. Now, what this means is, when you put the double quotes that we have done here, right? The double quotes, sorry, I'll remove all of these fancy colors. I'll draw this again. Okay, can I? No, I can't. Okay, never mind. Okay, so you see this little green double quotes, right? I have written hello as hard-coded, and I've put a dollar sign. Now, why I'm explaining all this is because all of this kind of plays into the Kotlin, syntax. If you know Kotlin, even to some basic level, Writing compose function then becomes much more easier. If you're coming from a very non-compose world or a non-Kotlin world, then these things become a little more tricky. Okay, what we've done here is we have taken a variable called name, which is coming in as an input to the function. Okay, that is what's happening here. Okay, now when you run this, that is what's going to draw on the right. Now let's say I want to change this to hello Mike. Right, Mike is just another name. How would I do about this? Now this happens because if I call the same function, correct? In the previous example, you might notice that name is equal to string. If someone updates something called as name somewhere else, not in this function, see, if you realize in this entire code, we are not writing state anywhere, right? We are doing everything here. This change of name from Adit to Mike is a state management or a state change, basically. That is what is happening here, okay? Now, when I take this into account, this is what is happening. So then the value changes from Adit to Mike, but nothing else gets drawn. That is the advantage of compose. When I say nothing else gets drawn, basically, if imagine there was a circle view, there's a text view, that thingy that we had, blah, blah. There were other elements. Only because this Mike got changed, only this fellow gets kind of updated. That's it. None of the other green things get changed from Adit to whatever state is. Okay, so we're going to be taking this example down the road, but I just wanted to show you how to do basic of declarative UI. Okay, now the most fun part of the entire ecosystem of Compose, modifiers. Okay, let's take this as visual example as possible. We had this text, right, which was very simple, right? So if you realize, oh, by the way, every time you draw something on a canvas is this region, by the way, wherever I'm drawing the right. This entire screen is starting from, sorry if I remove this, the way it starts downwards and goes right. Okay, so whenever you draw something, this is the 0,0 index. This is like the graph theory, right? Now, why this is important is because when you do this kind of logic, modifier dot padding 10 dp, what's happening is, if you notice, there is some space over here. Correct. Now, when you put the dot padding in the XML side of things, we used to do something called the margins. We used to also have something called the inner paddings. The concept has slightly changed. When you do something like this, modifier dot padding, this modifier is like the organizing, boss of the entire family, right? Like, hey, whatever this guy says, that is how the text is going to behave, and this is how the relational of text with its corresponding parent. A parent in this case is nothing but a box. We'll see what a box is later on, but this entire black screen that you see, wherever I'm drawing the blue, is that box that is getting drawn. Okay. Now, what's happening here is that when I say modify.padding, it's giving this this 4 spaces, whatever I've drawn here. That's what's happening. Okay. Now, if I add something called dot background, correct? Very simple thing. What's happening here is that the entire thing is just becoming a background. Now, if you realize, there's space over here. I'm taking a blue color. There's space here, there's space here, there's space here. Correct? Nothing else is got drawn here. This is how much the text view is. This padding 10 dp is giving space from the left edge, the top edge, the right edge, and the bottom edge. So if something else comes after this text view, let's say I write another text here. Sorry for bad handwriting. I'm using a stylus pen on a vertical screen. Okay, so if I put another text there, it will start getting drawn here, basically. Whatever I've written here, like let's say I've put an Adit over there. The reason for that is because this text, let's say I don't have any modifier padding. I just have a regular text, correct? Now, this is an exercise for you guys. When you actually do the code labs, you will actually realize when we start talking about, and by the way, modifiers has about, I think, 800 plus mutations. Mutations are nothing but modifier.padding, modifier.background. These are all extension properties, okay, in Kotlin. When I pass color.green, it is doing some behavior. And then what's happening here is it takes this block. Sorry, I'll change a different color. It takes this block. It first creates a modifier instance, then adds something called the padding value, returns a modifier in return, then adds a background color and returns a modifier in return. This modifier will have 2 values, padding and then the background. That's what's happening. Okay. Sorry, really bad handwriting today. Okay. Now let's say I don't want the background. I want something called the border. Correct? Now, when I do this border, what's happening is instead of the entire area where the text was drawn, it's taking the edges of the screen of that function called text and drawing a green color border. I can make it color.red. I can make it 15 pixels wide. The DP stands for density pixels. So that means if your phone is a high-end phone, then depending on the screen's density, it's going to change based on that. Okay. Now, if I do something like this now, what do you think has happened? Just carefully look at what's happening on the right on the Android phone. Do you see the hello world is compressing down? What happened here is that earlier this padding was not there. Correct? The reason is order matters here. So this padding, one second, I'm going to use the green color. The green padding is useful for giving spaces here. Does that make sense? And then the border is for doing this. This border code is for drawing this border. And the last final piece is the padding. So this padding is giving you this pink or purple, whatever you like to call this, correct? Now what's happening here is, compared to this, we were only sending the padding on the outside. And compared to this, we are sending the padding inside also. It's not an OR operation, it's an AND operation. So the order of these modifier parameters matters. If I move this padding to the very top, then everything then is very unique. Okay. If I remove this, then this is what's going to happen. Okay. Now, moving on, let's say I want the border and the background. In reality, what's happening here is that you see this little white lines. This is what is responsible for this, correct? And all the border and the background is for setting this, correct? Now, I made a small code mistake here. This should have been color.red. This is just a slide error. But color.red is responsible to draw the border. Sorry, I'll remove all the fancy drawings. And the background is what is for the color.green. Does that make sense? Okay. Now, there's a huge list of these. Now, it's a homework for you guys to go and start searching this list. You can take a note of this, but don't worry. I'll also provide you the slides at the end of the session, but you can always go back and check all of this again. Okay, moving on. Layouts. Now, this is something that is very fun. These are all the things that you're going to be using to build the UI in the first place, right? We have not come to the state yet, but just bear with me for a few more minutes. The first thing we're going to be looking at is columns. Columns is responsible to draw content like this. When I say content like this could be anything. It could be a card view, it could be circular image view or whatever. These are individual homogeneous content, or it could be heterogeneous. Homogeneous is when all males are standing. Heterogeneous is when there is a mix of female, male, and so forth. Sorry, very crude example, but you get the gist, correct? So imagine this was yellow. Yellow represents a different card view. Red represents a different card view. So if I have to build this, and we're not going to be building this card as an example, but just imagine I had to do something like this. I take something called as column composable function. If you open this code on your Android Studio, right? And when you go and click this column, it's another composable function, which has other mutations, okay? So when I do this, and let's say I want to draw hello world on the right side, what's happening here is I'm just putting 3 of those together. Now, the reason this happens is because column is always going to draw its children vertically. A very similar concept is called row, which we're going to discuss later. But just to kind of understand how column breaks down, you remember that little graph theory that I was very proudly explaining? The point over here is that everything starts at the 0.0, okay? The first move is to go down. Column will always draw all the elements downwards, okay? Now, imagine that in the column, there is one small circle, there is one big card, which goes the entire width of the screen, okay? And then there is one which goes like this, outside the screen. It doesn't actually measure how much this width is. It doesn't measure how much this is. It doesn't measure how much this is. A column responsibility is to draw it vertically down. That's it. Nothing complex there, okay? If I take this example, there's a property in the column called vertical arrangement. There's also something called horizontal alignment. Alignment is useful when you want to draw. Imagine if I remove all of this for a second. And imagine you have a screen like this, correct? A screen which has multiple elements. And you want everything center horizontal. So you can draw something like this there. Imagine you want it all horizontal to the start, then all of this will move to the left, starting from the left. So whatever you see here, right? In this case, the graph starts at the left edge and the top edge of the screen. And when I say vertical arrangement, always center align the vertical content. So whenever a content is drawn, it will first go to the somewhere here. It will first start somewhere here. Oh, sorry, let me remove all of this. It will start somewhere here at the center of the region of the screen. The reason for this is you could be, building something that scrolls only. So if you have a very big phone and you want the content to be very reachable to your thumb, so when you want to do something like that, you can tweak all of this. Okay. Next, if I change this vertical arrangement to space between, what's happening here is that we have oops, sorry. We have this little space that you see here, right? This red little, this is not drawn, this is just for visualization. This spaces that you see here is what is responsible for coming out of this thing called arrangement space between. Now, there are multiple mutations of this as well. Arrangement dot space by, arrangement dot space evenly, and so forth. When I say space between, it gives us equal ratio of this. Depending on how much vertical content can be drawn, it's going to draw that much. Just remember, a column cannot be scrollable just by writing this line of code. Okay, you can be putting 3 text views here, but it'll not scroll. If you have hundreds of text views, whatever is visible on the screen is the end of the column. If you want to make it vertical scroll, there's another modifier property. Again, modifiers play a huge role. Okay? Now, coming to the horizontal alignment, like I was mentioning before, when I want to move the code from the left edge to the right edge or center it in the horizontal x-axis, that is when I do something like this. So the same concept that we did before. By the way, if you're wondering what is this all about, all this empty space, this is the text view basically. This is where we wrote those 3 text. Correct? 3 text. Basically, that's it. Nothing fancy. If I want all these 3 text to be drawn on the right edge of the screen, then I would use something called alignment.end. There's a bit of a difference if you realize. Vertical in a column is called arrangement. In column, again, sorry, it's the horizontal is called alignment, correct? Because column is always by inheritance, is always going to give all its children an inheritance called please draw vertically. Okay. Moving on. Now, if I want to center horizontally, again, just a mutation of it, everything will be drawn like this, but again, vertically drawn, vertically placed, one after the other, one below the other, right? And everything will be horizontally placed in the center of the screen. Okay. Then if I want to do something different, I don't want a vertical list, I want a horizontal list, then you would use something called a row. Row very similarly has a very simple function name called row. You open a lambda, parenthesis, a curly parenthesis, sorry. You put text, or image or whatever, and it will draw like this. What's happening here is that we have hello, which gets drawn till here. Then we have world, which gets drawn right after it. And then we have an exclamation mark, which just gets drawn like this. Because we have not given any spacing or any vertical arrangement, horizontal, whatever, none of that happens here, correct? It's just drawing it, okay? Now, in a row, everything is from left to right first. So that's why now it's horizontal arrangement, okay? It's not horizontal alignment. In a row, because arrangement is responsible to draw in the direction of the parent, okay? When I say this, space between will make sure that it provides this. You see that space in between, right after the hello and the world. I've shown an example here, right? So this space and this space that is there is drawn because I've done arrangement.space between, okay? These 2 little red boxes, okay? Now, if I move on, if I want to vertically align as well, correct? Now, when I say a row, right? Let's say the row is only this much and there are other elements over there. Let's say this is the entire screen, correct? A row is always on the top or wherever you draw it in the order you want. So a row is always going to draw this direction. But if I want to vertically also place it in, like I want it to be on the top edge or I want it at the bottom edge, then you could do something like this, center vertically. Now, the reason the hello world went down is because I've made the row become the full screen and I've set center vertically. So over here, there is a bit of a code called modifier is equal to modifier dot. I've not written the whole thing, but fill max size. So depending on the entire screen, the row is going to be drawn. So what it means is this entire yellow region is the row. And because I've done something like vertical alignment dot center vertically, that's why the hello world comes here. That's it. Nothing fancy happening here. Okay. Now, just to kind of summarize, when you're working with column, a vertical list does not scroll. You can make it scrollable by using another layout or another property. But when you're working with column, remember it's a vertical arrangement and a horizontal alignment. When you work with a row, it's a horizontal arrangement, but a vertical alignment. Okay. If I combine these two things together, this is how this layout can be built. I would draw a row. The reason for that is I'm going to be drawing the exterior part of this layout. This entire thing is called a row, correct? Because I want to place, this is how it's going to be broken. This is the first child of the row, and this is the second child of the row. Okay. So when you see this code, what's happening here is that, I'm going to redraw that, correct? The image is coming here as the first child. The second child is this column, correct? The column is responsible to draw vertically, right? So we have two texts. That's the way to do compose code. As simple as that. Okay. Now, if I have to do something more complex, you remember I spoke something about a box, correct? A box is very fancy. A box kind of provides you with these fancy things that puts everything at overlapping stages of itself. So if you don't give alignment to any of these, then they will be drawn. Now imagine this. I want to draw this box that you see on the right with some corner radius, correct? And I want to put some nice puppy over there or a nice mountain, right? I'm going to draw some mountain, some photos, whatever. I want that image, which you see here, to be drawn in the entirety of the box. I also want some two text on top of it. If you've used the Google, what is that, Google Now or the Google search results, there are sometimes you see those news articles on the Google site, right, where the photo of the news is there, and then right below it, either at the bottom edge or at the top edge, you see these two text views, which says top news and then the title of the thing. So if you want to do something of that nature, a box is basically going to draw whatever that shape and size you want. And when you draw the image, you're going to make it either fill the entire content. Sorry, I'm scribbling on my screen. But if you want to draw, like some text, then you can use something else. And you can give this alignment of this fellow to be at the bottom edge of the screen. Okay. How does that work? You can do something like this. The way I've achieved this is by creating a box first, drawing the image. Obviously, I've not drawn an image on the preview, but you get the visualization, right? To the column, I say modify.align. And I say alignment.bottom end. It's not arrangement because box has no direction. Box is everything overlapping on each other, right? When I say alignment as a concept means that you're going to align it based relative to the parent. So when I say alignment.bottom end, it means parent is called box, go to the bottom of it, right? And that's why the two texts are drawn like this, okay? Now, moving on, the next simple concept. You've seen how to build those. If you see, right, I'm using rows, columns, boxes to build everything together, right? If I have to do something like this is where the list comes into context, right? If I have to build, say, a list of all the employees in my company, right? I will pass in items, a list of, a collection of all these employees, or I call them items. They're very inhuman in this example. I would use something called a lazy column. The keyword lazy here is that the intention of lazy column is, compared to column, a column will be drawn like this, correct? A lazy column will also be drawn like this. The blue is for lazy column. The difference is that this is the content region for column. That's it. Whereas in the lazy column, it could be downwards. I can keep scrolling down, or I can come back up, or I can go down again and stuff like that. So the entire page can be broken down into multiple things. Okay, sorry, removing the scribbles. A lazy column can use something called an item. Do not confuse it with this name. Item is a function. It's another composable function sitting like this. If you have multiple of those, then you can pass in. I know that I've written items twice, but just bear with me. Let's call it employees. Correct? And employees, just for the sake of argument. When I call another composable function inside lazy column, the scope, when I say scope in this case, scope meaning that whatever it's drawn in the lazy column, let's say the lazy column is from here till the the bottom edge of the screen, correct? This is called the lazy column scope. This is where the items are going to be drawn. Same for the row scope, column scope, and so forth. Wherever the draw region is, that is what is a scope in Compose. Okay. When I call this items as a composable function, it is written inside lazy column. Now, because it's written inside lazy columns, sorry, if I clear all of this for a quick second, it's written inside these lambdas. Sorry, not that one. This one. Because it's written inside this, it is now going to behave based on what lazy column tells you. So this is OOPS concept inheritance. Lazy column says I'm going to be 400 pixels wide and then 500 pixels height. When that equation comes, the items are only drawn in that region. And when you draw it, this is how it's responsible to do it. I have another compose function, again higher order function in reality. I have a custom function called item row. That item row is what we saw so forth. The row and the column and the box and the the fancy image view and all that. That's all. Nothing crazy there. Okay. Now, when I put it all together, this is how the list comes across. If I want a static header, you must be wondering, how do I do headers? I want to throw a nice past girlfriends, and current girlfriend, something like that. Sorry, I'm just joking there. But if you want to do some text over here and text over here, and the list is not going to give you that text. But if I want to do that, I can just call item, open curly braces, and just put a text inside there. Now, because this item exists inside this lambda, lazy columns lambda, or the curly brackets, this item is responsible to draw whatever you see here. And wherever, so lazy column, because again, it's a column, if you realize it's a vertical column, right? If you put this item over here, this is responsible for this guy then. Whatever you want to draw here. And these are just examples. These are not proper exercises, but I just wanted to show you, okay? Okay, now I'm going to take a small pause and I just want to understand if any of you have any questions, because chapters from here onwards are going to be a little more complex. So I'm just going to take a pause and see if there's any questions on the chat. If you have, please do send it. Java 19. Okay, yeah, that's actually 18 is the production, 19 is still being used for enterprise. So if you're a commercial user, then 18 is the correct answer for Java. Okay, any questions so far? You can raise your hands and we'll try to answer them. But anyone? Okay, Anshul, yeah, please go ahead.
Adit, I have this question. I've been doing this compose, right? And then this
Okay.
question always arises everywhere in the community as well. That you mentioned, right? That compose, when you are creating these composable functions, they have to start with the capital letter first, right? So
Mhm.
now, like when you have been coding and when you have made as a practice that no, every function should start with a small case letter, so it becomes your like habit that any
Mhm.
function that you write, it just starts with a small case, right? So I've seen a lot of
Right.
times I've seen this problem that I mean, unintentionally, right? Because it's become my habit. So I've made it
Mhm.
like a small case, right? And then it shows kind of a lint errors or something like that that should be capable. How can we deal with this such things with this?
Okay, so slightly advanced topic, but there's something called KT-Lint, one of the bike shedding tool, which basically checks for all these checks. You can build it for Compose, you can build it for whatever other language. Kotlin has its own linting, but Kotlin's default linting says all custom functions should start with small letter, correct? But when it Compose comes into the context, if you use something called KT-Lint, which is another external library, not a code library, it's just a tooling. The tooling also has something called the formatting. So it'll actually cry out to you. It'll summarize everything that this is the problem that I want. It'll also give you an automated one button click solution for that. It'll go and make all the caps for all the composable functions. If in case you missed it by hand, you can actually do it through the tooling as well. I use this for a lot of the junior developers that work with me in different companies. They're just getting started on Compose and they're like, sir, I forgot, sorry, they have raised a PR. I usually just ask them to format it with this tool and it automatically corrects. But as a practice, I also advise them, please remember this next time. So I hope that kind of answers you, Anshul.
Yep, thanks.
Yeah. Any other questions so far in Compose syntax? I know, sorry, Anshul, this will be a very basic down course for you. But then anyone else who has not tried Compose and has any questions so far, I just want to take a pause here so that if anyone has any questions, I can try and answer before I jump into the next slides. You can put it on the chat also, in case you don't want to come on the mic. That's totally understandable. You can put it on the chat and I'll try to answer. If not, we'll continue. I guess, okay, no questions. Okay, cool. So I guess everyone is like following along. Cool. Okay. Moving along, we also have something called the scaffolding. Now, what I mean by scaffolding is, the region that is drawn. So this is the status bar, correct? The bottom nav bar is at the bottom. If you are fancy like me and you like the iPhone pattern, then a lot of Android phones comes with these 5 gestures now at the bottom. But that region at the bottom and the top are called insets. INSETS, okay, insets. But if you want to draw content behind it, how many of you use Google Maps? If you realize Google Maps actually draws behind the content, or it draws, like this region that is highlighted here, toolbar. So when I have this kind of context to set in my Compose, you could use something called as scaffolding. Scaffolding is not just responsible for top bar; it is also can give you the bottom navigation bar. It can also draw. You can pass in, insets to the modifier, the padding of the insets. When I say padding of the insets, it means like this status bar and the bottom. Sorry, the graphics doesn't show it, but then this region, the status bar, can be a padding that you can give it to scaffolding. Okay, this is responsible to then push the content out. But if I have a top bar and I want to draw home, this is how it's going to be drawn. I can put a text view, I can put an image view, I can do whatever else. So all the custom, imagine those designs that you've seen on few websites or on certain apps that have custom, toolbar and not the standard way of doing Android things. All of those can be then built like this, because the goal here is that this is a composable function. Correct? It's a @composable lambda. You can pass in anything you want. You can create a custom function and then call it inside here. Okay. Now what's happening here is that when you draw the top bar, obviously you're also going to draw the list somewhere. So imagine that instead of this text hello world, you wanted that list that we just saw in the lazy column. You want to draw it. So what you're going to do here is you're going to put it inside this. If you want to do a bottom bar, then you're going to write bottom bar is equal to whatever the composable function. Okay. Now, in the code lab that we're going to be seeing a bit later on, we're just going to skim through it. But when you actually get used to writing compose code, you're going to come across instances where you have to do all of this. So scaffolding is your default answer. If you want to use, say, a scaffolding, when to use it, how to use it, that code lab will actually give you a better glimpse of things. Okay. But this is more of an intro to how to use this. But the intention is that when you think compose, it's all functions called inside functions. Okay. So forth, we have seen column, row, box, and scaffolding. There are many more. There's constraint layout, there's motion layout, and so forth. But for today's topic, we're just going to keep it very lean and simple. Okay. Now, we've spoken about layouts a lot. Okay. So we have seen how to modify it, how to do vertical arrangement and all that. But let's see how to modify them as well. Let's say I want to do something like this. Now, this is a very fancy layout that I want to kind of bring forth, right? I want to draw content which is padded on each side, but I also want to do certain background colors and stuff like that. So let's say I want to draw a hello world, correct? Which has two hello worlds, but with different colors. Now they're literally the repeat of themselves. So I've taken a column, I put two text views. I think in my slide, I think it is just broken. Sorry, this is how it should look like. This is how it should look like. But imagine instead of putting the background in each of those text views, I want to change the color of the column itself, correct? If I have something like this, and just for the argument, I'm just going to make this, sorry, bear with me. I'm just going to make this, let's say I don't want to pass this fellow in, correct? Sorry, I can't, oh, sorry, different keyboard. I have 4 keyboards in front of me. I'm so sorry about that. So, sorry, this is my bad. I totally forgot to undo this. Okay. So if I go back, okay. So when I do this kind of a column, right? And I say that for the entire of column, I want the modifier with background color dot green, correct? And I want to fill max width. The difference that I'm going to add here is, if you remember, I had also referenced something called box dot fill max size, correct? Or sorry, box modifier dot fill max size. Very similarly, there are these layout modifiers called fill max width. What's happening is this white thing. So it is dragging the entire column to be the width of the screen, and then the text are drawn. Okay. Now, similarly, if I do fill max size, that is what's going to happen. It's going to draw it to the entire screen. And imagine there is a scaffolding here. Sorry for the padding. If it looks off, that's just imagine there's a scaffolding there. And the green region is where the content is drawn. Okay. Now, imagine this. Again, I'm going to be doing this live, but then imagine this as the red. Now this will become red, but the text views will become, all the red boxes that you see are going to be becoming green. So that is what's happening here. So layout modifiers also have something called these fill max size and so forth. You remember that link that I shared you before? The modifiers, those are responsible for, there are thousands and thousands of these. You can go and check all of these out. Let's say I want to do dot width 200 dp. If I do width 200 dp, then that is what's going to happen on the right. It's going to condense the, the maximum width of the column to that much. Anything below that, it's always going to keep the min and the max at that much. There's also something called the default min size. You can pass in a min width, minimum width, or min height. That means by default, irrespective of the content, it's going to draw that much. If the content grows beyond that size, then the column is responsible to then draw beyond that also. But the minimum width should be, say, 200 dp. So then this is what's going to happen. Okay. Now, all these are very fancy and stuff, but then coming to the nitty gritty part of the compose state management. Now, this topic alone is a whole session in itself, but I'll try to break it down for you in a very crude and simple way. Remember that there is something called mutable type and an immutable type. This is another concept in the computer science world, where a mutable type is responsible, where at runtime it can change its value. Immutable type cannot. if you want to do that hello Adit, hello Mike kind of an example, we would be using something like this. So we set up a state called, when I say state, it is just a representation of what I want to do in the compose. When I draw hello Adit, hello Mike, I'm changing the state based on my requirement via mutable state of, okay? So, but let's take a slightly different example. Let's say I want to build this UI. Okay, now I'm going to just break this down, how all this works. This is a simple text view. This is a column with a text view and a row with two buttons. Okay, this is a button, this is a button. Button is another composable function. Okay, now what I want to do here is that when I click the plus button, the number 0 should go to 1. If I click it again, the plus button, it should go +1, +1, +1, +1, as long as I keep clicking the plus button. If I do the opposite, I click the minus, then the number should decrease. 0 is the bare minimum that I can hit. How would I write this code? In my composable code somewhere, I'm going to be writing something called as a counter variable. I'm going to be using something called the Kotlin delegate property. What that means is I'm writing by instead of equals to. You can also use equals to, nothing different over there. The advantage of doing this is this syntax, the remember logic. So when a composition works, correct? When a composition comes into the picture of rendering, the remember remembers the value for as long as it's there in the tree. A compose basically is a tree. So if I say I want a row, I want multiple children, sorry, a column. I'm so sorry, a column first, and then I want multiple children vertically placed. And each of these are rows. For example, each of these children are rows, and each row has its own, like a text view and some kind of state management or some value inside it. Every time I draw this yellow thing on the top right-hand corner of my screen, this is a composition tree. How does it work? It's going to be the compose activity. Inside it, it's going to be the column. Inside it, it's going to be the row, the row, the row, the row. And inside each row is going to be whatever that value is, correct? So different colors, they're all part of a tree. Just imagine like branches, correct? A compose is, think of it like a link tree, correct? So when I say remember, for that particular node of the compose, I am saying, please remember this value called 0. Someone else can come and modify it, but I want this to be an integer number and someone else is going to modify it for me. But remember that I'm going to draw text based on this counter. And when I write the language called by, the by is giving me the raw value. Instead of me saying, the counter dot value, when you work with compose, you're going to be writing, if I had done something like this, sorry, I'm just going to erase all of this. I wish I had an eraser somewhere, but apparently I can't. Okay, cool. Okay, so if I had changed this to equals to, and if I access this counter somewhere, I'll show you in the next slide. Counter dot value was the way to do this then. Instead of doing all of this, I'm doing a delegation. Delegation is like, hey, Mr. X, please do this and tell me what the final answer is. I don't want to be bothered with it. So it's kind of bringing that single responsibility in the concept. Okay. So you remember I told you that I want to be using the value as is. This is where I'm using it. So what's happening here is I have put a column and a text. I put a counter.toString. Why have I used column? Because I want column and one row with two buttons, correct? Now the button looks something like this. On click of it, I want to increment, like post increment the counter, a very basic math thing, right? And every time I click this button, if you realize the button has other values here. This is not here. I'm really sorry for the syntax mistakes here. The button starts here, the curly brackets. Anything inside the curly brackets is the content that you're going to draw. So inside a button, you can put an icon, you can put a text, you can put whatever else you want inside a button. I have defined the button to be the most smallest width and the most smallest height that I can, sort of like a wrap content. And inside it, I put this plus button. That's it. And same thing for the minus button. Correct? Same thing for that. Okay. Now, when I render this code, what's happening is every time the button is clicked, oops, sorry, my bad. Yeah. So every time the button is clicked, depending on whether the plus was clicked, then the number is going to increase. If the minus was clicked, then the 0 is clicked. So state management it's all kind of boiling down from here. Mutable state of. It could be a string, it could be your own classes, it could be any sealed classes. Again, these are all concepts of Kotlin, but then you can write anything inside this mutable state of. The return type of counter is whatever is inside the round brackets, the type of the return. Okay. Now, whenever I change that value, counter plus plus, correct? What's happening is that variable called counter is actually incrementing. And because it's a composition, correct? What's happening here is that the composition is now this function that I had written, the screen that I had written, is going to recompose. That is a very simple concept that instead of going through the entire process of redrawing everything, it's only going to see, oh, wait, I have this text. It is using this variable called counter, and it is a remember, and it's a mutable type. It's a state. So counter is the state over here. Now, just because, let's say there was another compose function here, correct? The whole screen is this green box that I've just drawn. This entire compose function is not going to be redrawn. Only just this text in this box is going to be redrawn, just because it's accessing a thing called counter, and because this is a state. That's it. Okay. Now you must be wondering, all this is great, but what happened exactly? What's happening here is, on a button click, I did the plus. The counter value became from 0 to 1. It sent that information back to the composable. The composable in this case was the function that wrote the val counter by remember mutable state of. It checked, oh, wait, I can remember this value, but the value has changed. So I'm only going to interfere if someone is reading this value. In my function case, the text was reading the value. So that's why the UI is going to be drawn. Now, only because text is redrawn, the entire that green box and the column and then the text, none of that is changing. Only the fellow that is changing the value 0 to 1 is going to be updated. So the buttons are not going to be redrawn. The column is not going to be redrawn. Only the 0 is changing from 0 to 1, and only the text is going to change. So just to kind of re-highlight, we had the val counter, remember by mutable state of. Every time the plus was clicked, the 0 became a 1, 2, 3, or every time the minus was clicked, only the text from 2 became 1 and then 0. Okay. Now, moving all of this again to the next little more complex example. Let's say I built that lazy column screen and I wanted to search something. I want to search all the employees I had, the previous example, right? Now, how I'm going to do this is through, something broke very badly. Okay, sorry, I'm going to draw this. So I'm going to be using the MVVM pattern. So in Compose, you're going to be managing states somewhere. The best practice is that the Compose doesn't remember the variable. So instead of writing composable function inside it, you write val counter remember by a mutable state of. You just remember this same exact mutable state of inside your view model, this blue section. Every time a value changes, let's say there is another button here. For example, or forget about a button. Let's say the search view. I start typing some Adit Lal, correct? This value will go back to view model. This fellow will trigger the event, and then the event will automatically update this list. So imagine it's a filter, right? Let's say there was Adit Lal, there was, John Doe, and there was Mike. So Mike doesn't confide into the results. John Doe doesn't confide in the result, but the result matches with Adit Lal because I had searched for Adit Lal. So this variable that I was talking about, the state is Adit Lal as a text or a string. That fellow is going to be sitting inside view model. I'm going to be writing val search field is equal to mutable state of double quotes empty string by default in the view model. Every time that value changes, the search view can trigger the view model. The view model will send an event down back to the list view. So if I remove all of this fancy colors, and yeah, what's going to happen is there is a lazy list, correct? The view model sends an event then updates the lazy list. Now, because lazy list is listening to the state, it's going to then behave based on that. You can also send it back to the search view, and then search view can tell the lazy list, or depending on the architecture. Okay. Now, all of this as a concept is great, but then we also need to do the fancy thing called a searching, right? Or even logging, or we want to do something only once, or we want to do it every time certain event occurs. How would you go about it? So side effect can be broken down in few different states, right? But let's first understand what have we learned so far, right? Recomposition, state management, the layouting, and so forth. But how does it all piece together, right? See, because when you're building Android apps, you're not just going to be writing search views and drawing the UI. You're also going to be talking to a data source, a remote API, or some kind of a database, and so forth. Correct. The first and foremost thing would be work. The side effects are going to be very useful there. Okay. Sorry, one sec. Someone at the door. So what we want to do this is that side effects are a way or a window where you can execute some other piece of code, some kind of business logic, but not completely impacting the composable function. So you want to just trigger something, but you don't want the composable function to redraw. Remember, the compose is a UI toolkit with two sides, right? One side is the runtime, one side is the UI toolkit. The UI toolkit provides you layouts, boxes, and so forth. Other side is where the reactions are, right? Or the business logic. Similarly, we have, sorry, any question? Sorry. Oh, Anshul, I think your mic is open. You had a question or?
Sorry,
Oh,
my best.
hey, no worries, man. No worries. Yeah, okay. Sorry. Yeah, okay. So we want some functionality of a code to not sit and render the UI, but also be outside it, right? We're then going to be having something called as like, hey, from this screen, open this screen, or open camera, or clicking this button should do something. So all these kind of logics, or if you want to show a network message, when a network goes offline or comes back online, how do you react to all of this in Compose? All of these are useful in the case of drawing a production app. And when you think about all these problem sets, then side effects come into the context. So we're going to be taking a look at three different side effects. One of them is launched effect, which is at the start of things. Side effect is more like when you want to schedule certain compositions, right? When a button is clicked, or when you want to lock something, or you want to talk to a network call or something like that, then you would, or rather, sorry, network behavior, then you would be working with side effect, or you would be dealing with something called a disposable. Sort of like the entry, the left side is the entry, the right side is the dispose or the exit of the compose function. When I say exit of a compose function, let me just kind of quickly break that down. How does it work? An exit is basically when the compose is no longer a node in the tree, the big tree that I spoke about. Imagine it is not even drawn, or it is not even on the screen anymore, or it's you have navigated from one activity to the other. That is when the disposable effect comes. Launch effect is when the composable is coming for the very first time. Okay. Similarly, there is side effects. Side effects is in the middle, where you want some state management and you want to trigger some effect out of it. Okay. So we're going to be taking a look at launched effect first. Okay. Now this guy is kind of very unique. It kind of gets triggered on the first composition or every time a key change occurs. Okay. So if I take that same example that I just did before, right? Counter, remember mutable state of 0, correct? It's some composable function. And if I say this code right here, correct? Launched effect, open another curly braces and say while true, it's an infinite loop, keep incrementing the counter, correct? And you must be wondering, hey, this is going to be an infinite loop. The UI will keep updating. But in reality, this is a trick question. What would happen in this case? There's a very unique example here. When I say launched effect, just because val is going to be evaluated once, true is obviously true, that value cannot change. Counter is incremented from 0 to 1. That's it, post increment. And anyone else who's using it, that text or the column, whatever that other composable function is using the state, is going to be using this guy, right? This number is going to only be executed once because launch effect is only when I have triggered it when home view is launched. Okay. If I want to delay it, by default, it should be 0. Only after 2 seconds, it should update to number 1. Then the delay as a coroutine. Coroutine is a concept of how to do asynchronous code, but delay is a coroutine. I can say coroutine of delay of type 2000 milliseconds. This will do the counter plus plus only after 2 seconds, and that's it. Now, I'm going to introduce one more thing here. This launch effect is basically just this code. Key 1 is equal to unit. Unit will never change in life. A unit is just like a void in Java. Unit is the fundamental building block of Kotlin. Unit can never be changed. A unit is like, I am 1 centimeter tall, I'm 2 centimeter high, whatever that is, right? It's a static number, the measurement tool, right? So when I say key 1 is equal to unit, key 1 is just based on this key, the launched effect will either get relaunched or it will not. If I had changed key 1 is equal to string, let's say the counter itself, if I had done something like this, instead of unit, I'd have brought counter here. Every time the counter comes, it'll automatically execute this piece of code, this entire thing that is here. But if I say make another state, a button click or something like that, then the launch effect will also get triggered. What happens here is that this fellow will be added to the, let's say this is the composable tree. Home view is sitting over here. Very bad handwriting with a pencil. But yeah, this counter is going to be obviously 0 at first. And I'm saying it's of type unit for now. It's only going to go after 2 seconds to 1 and nothing else changes. But if I make this unit, sorry, I have too much drawing now. If I make this unit go from, say, another state or another int number or something like that, whenever that fellow changes, this launch effect will also get re-triggered. And instead of re-triggering the entire composable function, only this part of the code will be executed. And depending on this kind of scenarios, you could be doing, like network calls inside launched effect. If you are saying something like, hey, I want to fetch the data only once when the screen loads, when the composable comes, You're going to show a loading. You remember the three states I told you, right? Loading, error, or content. Content is what gets drawn as a list view or whatever else you have. By default, you're going to show loading. You want to show it only once. Every time, say, let's say there's a push notification or something, or a backend sends you a new, dump of data. You've called another, someone has gone and scrolled to the very bottom of the page, or they have clicked the refresh button or something like that. That refresh button click as a Boolean state that was clicked can be the key over here, which is this guy instead of unit. Unit is just telling that this launch effect will be launched only once. And because it's only launched once, the while true, there's no kind of repetition logic here. While true, delay 2 seconds, increase the counter and be done with it. That's it. Nothing else will happen. Okay. Now, if I same thing, if I want to, kind of do it in the middle of the flow, when the composable is already drawn and there's something else happening, the screen is still drawn, the composable is still live. I just want to schedule some kind of, like an effect that occurs because of some event. For that, I'm going to be doing this. So you remember the search view example, right? Now, if you remember search as a bar, if you've used any Android phone, I'm giving a very Android example here. You're going to be having a search bar. By default, the cursor is not shown. The cursor is shown when the focus is there on that, correct? This kind of a logic that the focus should only be when certain thing occurs is a side effect. Now, it's not going to happen as soon as the composable is drawn or when the composable is about to exit. It's something in between. When the user interacts with it or when the user is pressing a button, then you want the focus to come. That is where the side effect comes into the context. So that is what is going to happen here. We have drawn a composable function called search bar. And the beauty of thing is that you have written a side effect, no key required here. You can put a logic inside this. Focus requester is another composable function, which can then be associated to a text input type field. A text input is nothing but your edit text fields, or a place where you can type your HUD's content out. Okay, so that variable called focused, it could be something else. It could be is Adit Lal driving right now or something like that, right? If that is the case, if that becomes a change, this side effect will get triggered. Every time that variable called focused and is search dummy is triggered, just imagine is search dummy is just for the context of things. It's just a Boolean variables. Whenever these two things are true, then the search bar gets its cursor or the focus is there and the keyboard pops up. So you can think of it that way. That side effect is something when the compose is already drawn, but you want to trigger something there. If the internet breaks, how do you detect even the internet is there or not? Correct? So that detection logic can be written inside side effect. And depending on that, then you can draw, say, an error view that, oh, sorry, your internet is broken. Would you like to retry? Connect to 4G, 5G, if 5G is alive. Correct? Now, similarly, when you exit the composition, let's say the screen is just about to exit, the compose function, that the component that you've drawn or the function that you've drawn is no longer required on the screen to be drawn, or it's hidden somehow. This is where disposable is very useful. A disposable can be very, very convenient. Let's say if you have a callback somewhere, you're calling an API and you're listening to a live DB query. You have db.fetch data and it's a live data. Not the don't mix it with live data as a class. Just imagine it's live resource. You want to remove the resource. You want to say, okay, boss, I'm done. Tea break. I'm going out of the composition. I'm no longer needed. I don't want your real-time updates to me. When that kind of a equation comes, there is this function overridden inside called onDispose. Basically, this guy. Every time the disposable, when this entire function called home view is destroyed, something like you have a life cycle of an activity, right? On stop, on destroy, and on pause. Very similarly, we have something called on dispose. Not to confuse with those three things, but just remember that every time this home view is no longer needed, this on dispose will be triggered, and you can then pass in anything over here. Imagine you were doing network checks, right? Like, is Wi-Fi even connected or not? You have to stop listening to that and Wi-Fi is there or not. Otherwise, you can be a memory leak. A memory leak in a very simple context is something that you have held on to. It's like an old photo of your, old, past girlfriend, boyfriend, whatever, right? They don't want you to have the photo, but you still have it. It's a memory leak, correct? So, sorry, very crude example, but if you want to terminate that completely, then you would be putting this together, okay? Now, just a one-on-one of what we have learned so far, right? Like all things put together, like what the hell happened? You're going to be writing an activity code where you're going to be either extending component activity or app compact. You're going to be putting a function called set content, and inside it, you're going to be putting a theme. A theme unlike XML, in XML world, we used to write styles.xml. We used to have then, I think, strings.xml and other XML driven components. A lot of those things would then govern how the component would behave. A button would have a color and so forth in the XML world. But in the equation of a compose, you could then use something called material theme. What I've done here is I've just built a custom theme around material theme. I also have my own open source library, which I'll show in a few slides down. The intention is that you want to control the theme across the entire composable. You want a white theme across the entire screens, you can control it here. You want to draw a certain color the way it is supposed to be, like black should be 80% alpha. You can actually do that here, something like this. So you want to say change the background of the entire app. You don't want a white background, you want let's say a milky white background, or even better, you want a little bit of badam milk kind of color, something like yellowish. So you can actually remove this line of code and you can put whatever color you want. Now, anything you draw inside this function will always be drawn with that as a background. So you don't have to do things like overdraw. In XML, we used to have this concept called overdraw. You remember that little code syntax that I showed you a couple of slides back? I had a column with background green. I had a text view with a color background green. Very bad idea. You can start avoiding that by just setting the entire background of the entire theme as, say, whatever color you choose. This is very powerful as a concept because then you don't have, this is where the composition local comes into context. This is slightly advanced for today's topic, but I'm going to give this as a homework. Just read the definition and try to see if you change the color, what happens. If you don't change the color, what happens. Once you understand that, then you can start writing more. And if you go and look at what my Andromeda as a library is, which I'll show in some time, it's another custom library built on Compose, but not using material theme. It's something that I built my own, just to show you that you can build your own theme as well. You're not tied down to something called material theme. Okay. Again, okay. So just a one-on-one catch-up. We write something called set content, open curly braces. We write a theme and then draw whatever composable function we want. You can have a bottom nav. You can have something called the navigation library initialize. All of that is right here. Okay. The more complex thing over here is this guy. The set content is responsible for doing the composable function. This is where the compose tree starts. The notes application theme or material theme or whatever theme you want to use. Even if you don't use it, by default, it's going to use a default theme that is packaged in the library. If you wrap it with your own theme, the advantage is that you can control a lot of factors, fonts, colors, and so forth. These two things are then responsible to kind of provide you with that, the binding the colors and stuff, so forth. And then the internal components. When I say component, this could be a home screen. This could be your search page. This could be the details page or whatever else, correct? If I take the very notes example. So when I do this code, this is what is going to get drawn. I didn't use any scaffolding. I didn't do any padding. I didn't do anything else. I just called that function called greeting, Android, correct? And if you remember from the previous slides, we had hello space dollar, the name that I passed. The name here I passed is Android. Just to kind of rebring the thought process, this is how it works. One thing with Compose is you also have previews. A preview is very powerful concept because you can just annotate @preview, another annotation. And as you can see on the right side, my screenshot of my Android Studio, I can actually see the component behaving the way it is supposed to. This text fellow, oops, sorry, I drew it above it. In this text, let's say I pass a modifier with padding 8. I don't have to run, go and find an Android phone to test this theory. If you just want to see how the color works or how the padding works and all that, you can just put up @preview, correct? Call this function, and it'll, when you build the code, it'll actually show you a preview right here. Oh, sorry, my bad. Yeah, and in this preview, any changes you do to the original function that you're testing, in this case, I'm testing the greeting Android, that greeting will then be drawn on the right. Fair? Okay. With this, I'm going to kind of terminate the theory session here. I'm going to be taking a small break. There's a big code lab here. There are 12 chapters to this. It's everything that we have learned today, but also whatever we've learned today is much more broken down versus something that the code lab is starting with. A code lab imagines that you are already familiar with Kotlin, you're already familiar with how a compose is driven and all that. But I want all of you to, even if you terminate right now, this session right here, I want you to go and try this session, this code lab today, tomorrow, whenever you get a chance. And if you have any questions, please reach out back to me. Correct. There are loads of these resources out there. This is one of the code labs, but if you understand the basics, you can then take this learning and then go to a more advanced. You can start building your own apps based on this. I hope this session was a little more useful, but if in case you are curious about how I did my own custom design, it's an open source library. You can find the entire app which is on Play Store, the bit.ly link, and you can find the entire GitHub source code of how I built an entire design system. There's icons, there's illustrations. How did I even set up a custom theme? I also have a talk on this. There are some, if you YouTube search me, I think there's an Andromeda talk that I've done with Android Worldwide as a, I think, channel. There's a YouTube channel for this. You can go and check out all of that right there. Okay. If you're just curious to, oh wait, I have learned Compose now, but what if I get stuck in something and I don't have, I have community support, but then I want to test some of the best resources out there, like what is the best way to do this or that. You can actually go to this website called jetpackcompose.app. Another GD from Canada has built this, another Indian. Jetc.dev is another amazing website to find all the things that you learned today. But if you want to try it in a different shape and size, you can actually go and check this out, jetc.dev. With that, that's all, folks. I'm going to still be there on the call. If you have any questions, I'll be happy to answer. If you want to find me on all the social media, you can find it on the link below. But if you have any questions, I'm going to just take a pause from screen share and we can take questions live. Yeah. I think I can see one hand up. Please go ahead.
Adit, I have this question that I've done this with view model, right? So I've done with this view model that your view models is attached to the fragment, right? When you do the fragment with view model and you do view models, right? When you try to get the view model by like view model by view models, right?
Right,
that way. Delegate, right? So you get that view model. So actually now the view model is bind to this fragment, okay? And now this view model, when it is bound to this fragment, it'll live until this fragment is there, and then once this fragment is gone, the view model will also go, right? Compose, we do the same thing, right? Hilt view model, with dependency injection, you can do Hilt view model. When would this view model go? Like, because I don't know, the Compose life cycle only starts with something like the initialization is started and all that. But when actually the view model will go away in this scenario when you do with Compose?
So if you use, again, for folks who don't know what Hilt is a dependency injection library. When you access that view model through that property delegate by Hilt view model, and then you pass your view model in, it's going to create an instance and it's going to tie it to the lifecycle of the composable function. So imagine you had a screen, and inside the screen you had other composable functions. The best bet that you can take for advantage over here is that you write one public function where the view model is passed and another private function which does the entire composable function. What I mean by that is, if you just visualize it, the intention here is that the public function is responsible to know how to get the view model. The internal private function is not responsible to know how the view model is there. You just pass a state. So this is called state hoisting. Not to confuse you with what your question is, I'm just trying to explain why view model is in this context of life. So when the view model is accessed on the topmost level of function, composable, as long as that function exists and it's there in the composable composition tree, it's going to remain. The view model is going to remain. If you want to share the same view model, which I've done in a lot of production apps, I built one feature where there's one single view model, but there are different API calls and so forth. The view model is going to be persistent across all of them. So as long as that composable function is there in the tree or a navigation graph, if you're using one, that view model is going to be inexistent, unlike a fragment. A fragment has its own life cycle. Composable obviously also has a life cycle. So when we do fragments, how it's going to implement internal logic, right? It's actually passing a lifecycle owner in the fragment example. In the composition, it is passing a composition local. As long as that object reference is there, it's going to keep it. And as soon as the composable dies, that screen dies, or that function, the top level function dies, this view model also dies. Yeah. Does that answer your question?
Yeah, got it. Thanks.
Cool. Anyone else with question? Don't worry. If you want, you can put it on the chat. We don't have to be, even if you're not done compose, don't worry. We're all, it took me 2-3 months to even understand how recomposition works. Even if today someone asks me how to visualize it, I'll be like, wait, I'm going to put one log. So don't worry. I've gone through the same phases. If you have any questions, please be free to ask. Even if it is generic Android or career based or anything else, I'm here. Anyone? You can raise your hands or you can put it in the chat. Okay, so in case you're still curious to see, what I'm going to do is I'm going to send my slides over to the organizers and then they will share it with you guys. In case you have any questions, if you have not noted down my link tree, one second, I'm just going to copy. Sorry, I wish, yeah. In case you just want to reach out to me, you can follow me on most of the socials on this. But if there are no questions, great. That means you've understood something. So I can actually take a quiz now, right? There's an exam at the end of the session. No, okay, cool. But yeah, if in case you want to ask me anything in private, you can please reach out to me. I have a public calendar as well. I do this for juniors, seniors, CTOs, CEOs, whatever it is. I have tons of people that come in and say, hey, Adit, I have this question I couldn't ask you before. So please feel free to do that. But with that, if there's no questions, thank you so much and have a wonderful weekend and a happy new year as well.
Thank you, sir.
Thank you, sir. We'll be circulating with our feedback form. Please do fill it to receive your e-certificates. I would like to request all of you to please turn on your cameras if you feel so. We'll take a screenshot as well.
People are too shy. It's okay. You'll be actually showcased on a really good website. Don't worry. We're not putting it on Twitter and all. We're going to put it on the Google website. Don't worry.
Yeah. Okay. I would like to take this opportunity to extend a sincere thank you to everyone who has helped us make this workshop possible on behalf of Google Developer Student Club, PHCET. It gives me great pleasure to extend my gratitude to Adit sir, who took out his time and helped us to conduct this workshop and impart his wisdom. I want to express my gratitude to our principal, Dr. J.W. Bakal sir, our HODs Divya ma'am and Rohini ma'am, and faculty coordinator Komal ma'am. I would also like to express my gratitude to GDSC BITS Pilani and GDSC Welltech teams for working with us on this workshop. Finally, I want to thank you all for attending the workshop and having a great time with us. If you all have any questions, you are still allowed to ask the questions.